Okay, now I can talk about important stuff. So yeah, last class I think I misspoke. When we were talking about get line, I said, oh, it automatically picks up on line feeds. And that's only the case if you don't provide it a parameter for a character, or if you explicitly provide the line feed character that it will do that. I totally misremembered the way I had written some code, so just make sure, like, I've seen a lot of people, not even in this section, like in other sections as well, um, use a semicolon to read the origin, I think it was called, in the cars CSV. So if you do that, it'll actually pull over into the next line. I can even pull it up really quick. Yeah, so if I had like this here, and I tried to read this, so if like the pointer in the file was right there where the cursor is, and then I tried to read until the next semicolon, it will read US and then also Ford Torino SW until it hits the semicolon. So just make sure explicitly in getLine you either don't call it with a parameter if you want it to stop at a line feed, or you explicitly call it with that line feed. Because I think I misspoke on that last time. And so the other thing I want to mention before we get started is that assignment 2 is up on the Canvas page. I might update the code a little bit, the skeleton code that you guys get, probably later today or tomorrow. It's due next Saturday, and I put it up early because I do think it's a little bit more difficult than the first assignment, so I wanted to give you guys as much time as possible, even though the first assignment isn't due yet. So I encourage you to get started as soon as possible, and I gave a little bit more time on assignment 1 than it seems like some of the other instructors did, so that's why I'm kind of overlapping them. So not to throw too much work on you, but I just want to make sure that you have ample time to read it if you've already started working on like assignment 1. So no pressure, just, work harder. Okay, so there's that. And then assignment 2 I will go over hopefully on Wednesday. I want to get through it, or at least talk about it before break, because we have a break on Monday, next Monday, September 7th, for Veterans Day, I think. When can we see you during office hours about assignment 1? Sorry to interrupt. Oh, no worries. So I'm assuming people aren't getting the email because it seems like this one didn't send out either. I'm holding office hours on WebEx because I'm not allowed to do it on Discord anymore. So either send me an email if you want to get into that, or check WebEx after this and see if it actually lists my office hours. If it doesn't list my office hours, send me an email and I'll try to fix that. Monday's Labor Day. I get all the holidays confused. Thank you. Yeah, so Labor Day is Monday, so we don't have class. But still, if you have questions and you're working through the assignment, message me on Discord or an email or whatever. Yeah, it is Tuesday, Thursday, 12 to 3, and it's on WebEx. It should be sending you an email out before my office hours, but it seems like it just sent all the emails when I scheduled it instead of the 10 minutes before like it was supposed to. I think that's why everybody was confused. Actually, I meant to ask one more time. Did anybody manage to join this meeting via the WebEx client rather than the Discord link or the Canvas link? Hopefully it should actually display that on the schedule. WebEx link. Yeah, it seems like everybody joined via WebEx link. Oh, via the email. Oh, or no, yeah, I specifically sent you an email. Okay, so it seems like everybody got the link. Okay. I'll try to figure that out. Hopefully it actually sends emails automatically and I don't have to keep posting. Came 2 minutes before class. Oh no. Well, I guess at least it worked. Okay, well, I guess it is sending emails. But if it just, is too late on it, I guess email me. Okay. And definitely double check the WebEx client after class and see if it has it scheduled. It hopefully should, as long as you're logged in with your email. Anyways, I guess all that stuff aside, I guess we should talk about programming, right? Because I think that's a good idea. So I've pre-written a lot of code here, and I'm going to get rid of most of it. But I wanted to do a bit of a practical example on classes for the next 2 or 3 lectures. So I'm going to keep most of this code, and I probably won't explain it. We're just going to assume it works. But let's just see what it does really quick. So I have a terminal here, and I've created the world's worst platformer. So every frame it will ask you, hey, what input do you want? Left, right, up, down, or jump. So if I hit right, you'll see we have a player there and an enemy there. And so it'll ask me for an input every frame. You'll notice gravity is getting applied, and as I hit right, the player is moving right. So I keep typing an R, and it's right. They hit a wall, doesn't do anything. I can type left, it moves them left. I can press J, and it will make them jump, and then fall back down. So our goal is to make this actually work. I'm going to get rid of my code, and we'll make it work where we can make this game. Everybody clear on this example so far? I'm really just going to create classes because I think it's a fair example. Okay. So first things first, I have these 2 classes. We're going to get rid of these. I'm at least going to comment them out. And we're going to write these ourselves so that we understand some structs and some classes and how to use them. Okay, so let me move this over a little bit. So first things first, does anybody remember the structure that we were going with for creating classes? What kind of file does anybody remember that we usually put those in? I know I only did one example, so if you don't remember, that's totally okay. Yeah, awesome. Header, right? So I'm going to go over here to the header files in Visual Studio, and if you're just doing this naturally, you just want to create a .h file. And I'm going to add a new item. Should open a dialog, and I'm going to create a header file. So in this case, I'm going to create something called gameObject.h, and that will just house all of our game objects that we're using in the game. Okay, so we'll add that. Right. And so what I'm going to do is I'm going to create 2 things. So I'm going to create one thing called a struct, is a struct vector2, and yeah, maybe it's a better idea. I'm going to call this a position. And then I'm going to have to update some code, I guess, for that. Just to not have some confusion with this kind of vector. Okay. And I'm just going to use this to store the x and the y coordinate for any given game object, and we're going to use that in a second. And then I'm going to do 2 other things. I'm going to write this code, and somebody tell me what this does as I'm typing it out. So I'm going to do 2 things here. Oops. Does anybody remember what this is called and what it does? Constructor. Okay, awesome. Yeah, good job. So these are both constructors for the position struct. And remember that a constructor is something that gets called whenever we start using an object, or we instantiate it or declare it. It will go and call this. So whenever I create a new position type, it will go and it will call either one of these constructors. This one if I provide no arguments, and this one if I provide 2 integers. And so this one just sets the position to 0, 0, which we'll just say is the origin, and this one sets the position to x and y, whatever is passed. Okay, so hopefully that's pretty clear. And then I'm going to create a class called GameObjects. And this is going to be the actual game objects that we had in the game that I made. So there's like the player and the enemy and anything else that we want to throw in there. We're all going to use just this one class and basically modify it as we want it to be different objects. Okay, so I have a couple things here. So for one thing, I'm going to do private character, print character, and so this will be their representation on the screen when they get printed. So for player, this will be P. For enemy, this will be E. And we can make it whatever else for everything else. Yeah, I'm going to give it a position. And then I'll write everything else later. So we're going to give it a position that marks where it is on the screen. It's X and Y coordinate. So I'm just going to call that position. Okay, and then we're going to create some public variables. I think these were all methods, right? Functions? Okay. Yeah, so it should be fine as now. So, let's see here. So for one thing, let's go up here, and if you remember, the way we include header files is we just give the name of the header file as a string. So I could say include gameObject.h, and now it will read from this file, and it says, wow, that exists, and goes here, and now that's all there. So let me change these to position. Actually, okay, so that should fix a few problems. Ah, okay, so I have to create that. Okay, fair enough. So we have a few things there. So, yeah, the reason I came back here was, let's just say I went down to, so I've already written a function for the sake of time called printScreen that prints everything to the screen, and then I have a two-dimensional two-dimensional array where X is like the number of spaces that we have going horizontally, and Y is the number of spaces that we have going vertically. And the position that it was being drawn on the screen there with the character was like its position in this array. So if I go down here, and I'm kind of cheated because I already wrote it earlier, but if I was to try to move something to the screen, so I have something called add object to screen, which just takes the position of the object and it puts it on the screen at that position in the array. So obviously the way I would do that is, if I have this screen array, which is a two-dimensional array, I would just put it at the X coordinate of the object and the Y coordinate of the object, right, if I wanted to go to that exact location. So I might do something like object.position.x and object.position.y. And you'll see that there's an error popping up. So does anybody know why I'm getting that error? First off, and how, well, actually, I guess we haven't talked about how we can avoid it, but does anybody know why I'm getting that error? And it has to do with the GameObject class. So I have this stuff here. So why wouldn't I be able to access position? Private. Yeah. Yeah, you guys got it. So it's a private variable, right? So we talked about this last time. Private variable means that you can't access it unless you're inside of that class itself, and a public variable means that we can access it anywhere. So this is a private variable, which is why it's giving me an error. And you might notice I cheated a little bit here, and I don't actually use the position in my real code. So let's go about doing that. So obviously, making something private means that I can't really use it anywhere else. And you know, maybe that's not a good thing, because maybe I actually need to use it. So in this case, what we're going to do is there's two things that we can use. So in the textbook and probably in the syllabus, I called it a mutator and a accessor. But I also used the term getter and setter, which is what C# uses as the name. You'll see them pretty much used interchangeably. Getter and setter, I think, is pretty straightforward and tells you what they do. Mutator and accessor is probably what you can expect to see on the tests, because that's like the formal, terminology. So I want to be able to actually access the position and access the character so I can print it, because other things need to be able to use it. I can't just, throw it out here and, have it do whatever, because I can't access it. But I also don't want anybody in another function to be able to overwrite the position or overwrite the character that I'm using to print for these, because if I do that, then they might accidentally change things during the execution of the program that I don't want to be changed. So that's where accessors and mutators come into play, is we will do something like public, like this, and then I will do character get character, and all this will do is it will return the print character. Okay. And then I will do a position returning function called get position, and that will take no arguments, and all it will do is return position. So now this is good because we can get both of these, but we can't overwrite them, we can't set them. Does that make sense as to why we would want to do this? Limit the ability of other people using our code to actually modify it, but still allow them to interact with it. Don't see any questions, but if you have any, just stop me. Okay, so you'll notice that should fix the problem that I had. I mean, there's still probably some other stuff, but I had the get position now actually gets the position, and I'm able to use it, but I'm never allowed to modify it, which is great. And I'm going to modify it in a second, but it's going to be a little bit different. So these are mutators, and I'm sorry, these are accessors, because I'm accessing the data with it. And I'm not going to actually use them, but if I wanted a mutator or a setter, then that would look like void set character, for instance. Character, new character, and then I would set the print character equal to that new character. Okay, so I don't really want this because I don't actually want to overwrite it. I don't have a need to. But if I did, I could create a variable that a function that both gets and sets that specific character. And you'll see in the assignment that the skeleton code you have does both of them for a lot of variables, and you would kind of wonder, well, what's the point then? Because if that's the case, I should just make it public if I'm allowed to get and set. And I think that's a fair argument. Just some people will do both a get and a set, and then just make the variable private. And the reason you do that is to just make sure that the person using your function is like 100% sure, I want to set that, I want to get that. So you write something that explicitly says get or set, so that it's clear that that's what's actually happening. Because sometimes, maybe you're just glazing over the code and you see an equal and just don't think about it. I don't usually do that, but, some people do that for, like, programming practices, just to make it easier to read. Okay. So let's write a couple other functions here. So I feel like I should move these. So I have the resolution of the screen. If I move these to the game object, it should recognize them because I'm not using any sort of namespace for these. So if I save this, hopefully it still recognizes res X and res Y. Yeah. Okay, good. So you can also, I guess, as an aside, and we'll hopefully get to namespaces sometime soon, you can also put variables other than just class declarations in your header files, and it will recognize that here as well. So you'll notice it does res x and res y and notices those, even though I have them in the header file over here, because it just really copies it up here. So on top of that, I think I'm going to move these and talk about them for a little bit. So I currently have some, they should work in a header file. I currently have some things here. And let's just talk about two things related to this. So you might have seen these before, you might not have. These are preprocessor directives for constants. So normally we do just like const int res x, const int res y, right? You can also actually go and define constants at the top in this way. So what I've done here is I've made some controls as integers, and there's two reasons I've done it this way. So one, you'll notice I can go and handle controls in my game, and I can use these names later. So whenever I use the name left, right, up, down, it basically fills in these numbers for it. So you'll see I have a function here that handles controls. And it gets the input from the user, so either L, R, U, D, or J, and it turns that into left, right, up, down, or jump. You'll see if I scroll over it, it says that left expands to 0, right expands to 1, up expands to 2, and down expands to 3. So it's very nice to have, something convenient like an integer to handle, controls or, some sort of thing that we need laid out. But it's not very readable if we just use the numbers. So if I said, like, if case L returns 0, case R return 1, and I just did it the numbers anyways and kept it in my head, then I'm prone to make errors later if I was like checking controls and, oh, what is left again? Is it 0? Is it 2? Is it 3? And I might forget. So what we can do is use these preprocessor directives to basically create constant variables with this name and that value. And so your next question might be, well, why would you even use that versus just normal constants? And like all preprocessor directives, so anything I put this hash in front of, the compiler actually takes care of it at compile time versus when we do a constant when it gets set at runtime. So these are actually a little bit faster if I do it this way, because the compiler will basically look at all of these, it will find the name, it will look at the number, and it will replace all of the names with the number when it actually generates the code, which is great. It just, it sets all of that. It will take care of it before you actually run the program, so we don't have to worry about the extra time it takes up to set all of those. Do these preprocessor directives make sense so far? They're basically just another way to do constants, but a little bit more efficient. And it leads me into another thing that I wanted to talk about. Okay, so I don't see any questions on that either, so let me open up a whiteboard really quick. So, you might also be wondering, like, wow, that's kind of annoying having to write out all these numbers. And you're right. The main reason you would do this is A, it's kind of fast, and B, I could do something like this where I set it to whatever number I want. So I don't have to strictly do what I did there where I said 0, 1, 2, 3, 4, 5. I could make these any numbers and they'll work. But let's just say I did have a case where I wanted these to be, straight in a line, just counting up, or I didn't really care about what the numbers are. There's nothing important about them. What we can do is an enumeration. So I'm going to really quick just write out an example of that over here. So let's say you were writing a program that needed to use the days of the week for some reason. So you would have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And so when you're checking these things, you might... Oh, I should double check that nobody's waiting. I don't think so. Okay, good. Actually, did everybody manage to join? There's like 26, that's pretty much everybody. So I think a common sense way, if we had days of the week, and I wanted to use these, so obviously I can't write the names of all of these, just, in my code and expect it to work, and I can't. And if I just used numbers or some other system like that, it would be kind of annoying, or at least difficult to remember. But I think the common sense way to enumerate these would be 0, 1, 2, 3, 4, 5, and 6. So I'm going to use the term enumerate. So when I say enumerate, all I mean is assign these arbitrary values that we're going to use in the real world as numbers in the computer, because that's a lot more convenient. The computer knows how to deal with numbers, and that would be a good thing to work with. So a common sense enumeration for that would be just make it go up there. And if I did it with the preprocessor directives that I was just using, I would have to physically write out Sunday 0, Monday 1, Tuesday 2, and that's kind of annoying. So the way we can get around that is with enumerations, hence the name enumerate. So let me pull that up really quick. What's the button I press again? This one? Nope. I just have to close this. Is everybody clear on what this is before I close it? Hopefully that makes sense. Just count up from Sunday. Okay, I don't see any questions, so I'm going to hope that everybody gets that. So I can actually have it do something like that in the code. So if I wanted to, we have the keyword enum, and that will automatically enumerate things for you. So I could make an enumeration called day, and then we initialize it the same way you do like static array initialization, where you use the curly braces. So what I could do is I could make one called Mon, Tues, Wednesday. I guess Sunday would probably be first. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And now I didn't have to type out all those preprocessor directives. And you'll notice if I scroll over them, Saturday is 6, Friday is 5, Thursday is 4, Sunday is 0. So we have a very convenient way for it to do that for us. And it's called an enumeration. And I probably won't be using it a whole lot, but I want you to be aware of it because it is pretty useful. Everybody clear on enumerations? I'm going to probably delete this or comment it out at least. So just something to be aware of. It might show up on the test. I don't know if it will really show up in any of the assignments, but very nice thing to use. I use it pretty frequently for days of week, and let's make it constant. It generates all the constants for you. So again, if I delete this, just by writing this out, it sets Sunday equal to constant 0, Monday equal to constant 1, Tuesday equal to constant 2. And all of these can't be overwritten. I can't assign to them. They're not actually variables. Actually, I guess just to clarify, if I wanted to use it, so if I wanted to use, let's just say Wednesday for some reason here, I would do x equals day Wednesday. I think if I actually put Wednesday, it should work still too. Yeah. So if I just put the name of the enumeration, it will do it. If you happen to have multiple enumeration types, so I gave this type is day, the way you tell the difference between them is with double colon, the scope resolution operator. And we're going to talk about that in a little bit. Yeah, you can just use these straight up. So the compiler will generate it for you, which is great. You don't have to write all this stuff out by yourself. Super useful. I use it all the time for days of the week, or like modes if I'm writing an application and I have like a mode where there's like an admin mode or a user mode, or like you can view multiple things. I'll just use an enumeration type to tell what it's in. Or controls. I've written games where I use controls and I just enumerate them. Okay. So now that we're off that tangent, oh, yes. If you were to put in a switch, since each of the days have a value attached to it, would it be switch day with the cases? Yeah, okay, good question. So C++ is a little strange about it. I'll show you the way I would think to do it, and then there is like an alternate way to do it, because C++ is kind of loose with the way it handles things. So these are really just integers. So it does allow you to set to an integer without explicitly, making some sort of distinction. So if I just made a void test here, just to put this stuff into. So yeah, if I had that, I should be able to say day. Maybe C++ doesn't allow that. Oh, no, it's because I commented it out. That should fix it. Yeah. So I can create an integer or a day and do something like that. So if I said day equals Sunday for some reason up here, then I could do switch day. So I need to use a variable with the switch because it needs to be an instance. And then, yeah, you can actually do the same thing. So I could say case Sunday, do something, break, case Monday. So I can give all of the case things just the enumeration as well. Which is also good because this is very readable compared to doing 0, 1, 2, 3, all that. And the thing that C++ does that other languages don't is if I use this integer here, because these really are just integers, right? It just makes it for me. It will automatically assign it to an integer, and so the switch statement works with integers as well. It will convert that integer to its corresponding enumeration, or rather, it will probably set all of these cases equal to the number as far as the compiler is concerned. Does that answer your question? Cool. Okay. Yeah, so very nice. You can just replace all of these integers with actual names, which makes it so much more readable. So I've done that with the controls, essentially. If you noticed earlier, I did have a switch statement with all of these as well for handling controls. Okay, so back to our game that we were making. So we have a way to get characters, get positions. It's also nice for us in a class, which is kind of the great thing about object-oriented programming, to throw functions in here that actually do things that correspond to that specific class. So when I have a game object, I want it to be updated in the game, and I probably want some other things. So I want to be able to move the characters of the game objects, because if I didn't, the game would do nothing. It wouldn't be very interesting. So I'm going to add a couple functions here that I've already written. So I have void update, and this is the way actual game engines usually work. So below my accessors and stuff here is I'm going to create a function called void update, and what this will do is we will call it every single frame that our game is running. So in this case, every time I do an input on the terminal controller, it will update every single object in my game. So I want all of them to be able to update. So anytime I create a game object, I want it to be able to update, and all I have it do in this code here, which I'm just going to copy and paste, is I just have it right now apply gravity. And we could expand this and make it look nicer, but all this does is it takes the position plus position.y and it subtracts it by 1, so it moves it towards the ground by 1, and then it checks if the position is less than 0, in other words, if we're below the ground, move us back up to the ground. Okay, so we'll use that function, and then we have a couple other here. Going to copy and paste these. Okay, so we have another one. So earlier I said I'm not going to use a mutator, but I do want to be able to adjust the position, because if I couldn't, then it doesn't make for a very interesting game, right? So I have one that doesn't set the position, but rather adds to it. So I'm going to have an x component and a y component, and it will add that to my x position and my y position. And then I also wrote another function that I guess I'll copy here, move in bounds. And what this does is it basically does the same thing that that this did, where it checked, oh, if we're below the ground, move back onto the ground. So this checks if you're past the left wall, move to the left wall. If you're past the right wall, move to the right wall. If you're above the ceiling, move to the ceiling. If you're below the ground, move to the ground. So it basically just stops any objects from leaving the play area. There's that move and bounce. So I've created a couple functions here. The update, which will apply gravity. I've added add to position, which moves a player or object in general by the X amount of movement and the Y amount of movement. And then I have two constructors here. So these are probably the most important part. So I need a visual representation for everything that's on screen. So for what I'm doing, I've just decided to give them all characters. So what I've done is, if we don't give a constructor, or sorry, we don't give it a parameter in its constructor, it will just make the character into a space, so it doesn't appear to be anything. And then I have another one here where we can provide a starting position. So this will tell like the spawn point that the object starts at in the game, and it will set that. So I want to talk about a couple things with this. And then I have a symbol here, which is the symbolic representation. So you'll notice in my main body here, I create a player and I create an enemy. And I'm creating a position 4-3 to start the player at. So the player will start at the position 4-3, and the player will have the character P to represent them. So notice that this is a position and a character. So the constructor that gets called will be the one with the position and the character. Right? And then I do the same thing with an enemy. I give it a position, I create a position, and you'll notice I use a constructor for the position as well, where this is the X and this is the Y. Again, that was this constructor right here. And then I give the enemy object a deal where it is represented by E. Right? And then I basically loop over this. I clear the screen. I handle the controls, which we'll talk about hopefully, maybe. And then I do some stuff. So you remember that I created that function add to position that moves any given object. So what I do here is when I read the controls, you'll see I use a switch statement with those preprocessor directives that I used. So if we read left from the player, which was 0, we will add to the player's position -1, which is to the left, and then 0 to the Y. If I get a right input, I will add 1 to the right, 0 up and down. And if I get a jump signal, I will do nothing left and right and move up by 2. And that's just to offset the gravity. Okay, and then up and down don't do anything in my game. Alright, and then I guess the important thing to take away, the reason I was talking about this, is I can add this position to just the player. So the player is an instance. I can do things to it and use the functions that come with it to affect just that instance. So when I was playing my game, right, when I put in right or left, it only affected the player game object and not the enemy game object, even though they're both game objects. So I can, with these instances, apply things directly to them. So that's the great thing about object-oriented programming and all of these functions that I can give to it. So the player is able to use that function. Right, and so again, similar stuff down here. The player and the enemy both have an update. So I can call those every single time I want them to both update, and they'll both do their own thing whenever they are called. So this player.update will update only the player, and the enemy.update will update only the enemy. But they have both of them because they're both game objects. So they follow that class declaration. And then I just have one here that adds the object to screen, and that's really just for the rendering part. And then I have the print screen. Okay. Is everybody clear as to these advantages of using object-oriented programming? Is that I can kind of create these instances, these exact objects of a class, and then use them in a way I see fit. Or if anybody has questions, please stop me. guess keep going. So, yeah, I'm able to use all those functions that I wrote and not really even know what they do. I just kind of use them. That's one of the advantages of object-oriented programming. Okay. So, yeah, let's talk about this constructor, because there's two things going on with it here. So the first thing you'll notice is that I use the parameter position. But this is called position. So if I was to remove this thing that I put here, what is this going to do? If I set position equal to position, I have two positions. I have this parameter position, and I have this member position. So if I was to do position equals position, is that going to do what it should do, or is it going to do something strange? And what exactly is going to happen? Which position is it using? On the left and the right, I guess. Anybody have any guesses? I can actually pose you the same sort of question because you've probably done something in 135 like this. So let's say I wanted to make a global, and I call it int x. And I say int x equals 5. And then I go down here into my main body, and I say int x equals 3. And the compiler doesn't get angry at me for that. So C out x. What would this print? Would it print 3 or would it print 5? 5. I'm seeing a couple 5s. I'm seeing 1, 3. 3. Okay. Let's find out. Let's run it. And so it's very small, but it printed 3. Yeah, exactly. 3 is in scope, 5 is not. So, yeah, that's kind of strange, right? This one got printed, this one did not. And the reason that is, like somebody said in chat, is because of the scope. So whenever I create a variable, I can actually overwrite the name of it. And whenever I create a variable, it exists in that scope. And for the sake of our class, let's just say scope is the body that it's in. So the scope of x equals 3, this x right here, is this, or actually, I guess right here, where it's created, until we exit out of the function right there. So whenever I create a local variable, it's only able to be used in the local scope. So x can be used anywhere within main, and then once I break out of main, it goes away. So if I was to, for instance, try to use x in, so let's just say I go down here, so the first thing that gets called is clear screen. So let's say whenever I clear the screen, let's just print another x. Print screen. Yep. X. Okay. So this one's not getting called in main. So which x do you think is going to get printed for this one? Is it going to be 3 or 5 for this one instead? Seeing a few 5s. Let's find out. 5. And it moved it. Oh, I have to input a control. That 3 is from the first 3 I printed. And you guys are right. It's 5. So, why is this one 5 and that one 3? Well, like we were saying, this int x only lives in main. If I ever exit main, that x, I can't use it, basically. It's still there, but I can't use it. And so, when I do that, it will look for the most outward x. So I might want to, again, open this here. We won't go into too much depth, but whenever I create a new scope with curly braces, And you can't just put the curly braces. You're assuming that there's like a while loop or a function name or whatever for these. Int x equals 7. C out. Oops. Not right. C out x. I can't call anything else. I'm in global scope. This program will print... Actually, what will this program print? Seven 3. Yep. Yeah, you guys got it. So this will print 7 and then 3. And then... so whenever I create a variable, so let's just say this is red, this is blue, and this is green. This x will live until we hit the end brace there. This x will live until we hit this end brace here, and this x lives for the entire program because it's at the global scope. So I could use these x's anywhere where I have their corresponding colors. So this x can be used from there to there, there to there, there to there. And so whenever I use an x, what the compiler will do is it will look for the most recent like enclosing scope. So when I call this x right here, it will say, well, what's the one that's closest to me? Well, it's the green one. It's the one that's inside the scope, that one. But if I call it here, that green one is no longer alive at this line, right? It was only alive from here to here. So it will call the blue one instead. So basically, if I was to draw these kind of like going in, it will look for the one that it hits first going outwards. And there's more to this than this from a technical aspect, but this is the general idea when we're programming. Does anybody have any questions on that scoping stuff? Why that would print 7.3 as opposed to anything else? I don't know if there's a way to just make this go away. I guess not. No. Okay. Well, if you need that, I guess it's always in the recording. Okay. So that's the general idea with scope. Why did I even talk about that? I don't remember, but good to know. Oh, right, I remember why I was talking about that. Because we were doing a constructor. Let me remove all these x's. Right, so let's carry that knowledge back over to what we were doing. So we were looking at this game object here, this constructor. So I gave the parameter position, and previously I'd been just giving them different names so we didn't have this confusion. So I have this parameter position, and then I have one in the scope on the outside of this, also called position, that's of the same type, and that one belongs to game object. So if I did this one here, do you think it's going to use the parameter position, or do you think it's going to use the game object position when I do position equals position? Or is it going to miraculously say the game object is on the left and the actual local to the function is on the right? Who knows? Maybe this works. But the fact that I had different code would probably tell you it doesn't. Any guesses as to which one it's going to use? I guess not. So this one right here is going to be this position and not this one. And the reason is because, like we said there, the scope of this position is its function. So its scope. So this position, its scope is from there to there for that one. But this position variable its scope is the entire class and anything I do with the class. So when I go to use this one, it will look for the most recent one in terms of its scope. So that is that one right there versus the one at the top. So if I did this, all it will do is it will take this position and it will set it equal to itself, which is obviously not what I want to do in a constructor. What I want to do, since I'm initializing something, and that's what a constructor does, is I want to set this position equal to that position. And so what I've been doing previously is just giving them different names and assigning them, but we can actually make a distinction between these, and I want to bring it up because it's a very useful, very important keyword, which is the this keyword, which you should always spell right, unlike me, in order for it to work. So when I call this, and we'll go over what this arrow means in like a few weeks, when I do this arrow, whatever the name is, it will say I want the position that belongs to this instance. So in this case, the position on the left here will be this one, because this one is the one that belongs to a game object. And this one on the right is just the normal name, so it still uses the parameter position. So this will actually do what we wanted it to do. It will set the position that we're given here from the parameter, and it will set it equal to the position for this instance. And I can use the same names, which is more of a readability thing. We can use this for some other stuff later. But yeah, so that's generally how we go about doing that. Does that make sense with this does? Okay. Stop me if you have a question on it, but we'll keep going. So the other thing that was special about this constructor is that I passed in a symbol. So this was the symbol we were using to display the objects, right? So I used P for player and E for enemy, and I have it here set to space. And this might look new. I have an equal sign in my formal parameter list. Let me actually, maybe just for the sake of making this a little bit more readable, let me move this down. Okay. So I just take this symbol and I set it equal to the print character, which is I use for printing. So what this will do is this is a default parameter of space for symbol. Let me actually comment some of this out. I'll probably post this code in like a week on Canvas so that everybody has it, and sets this instance object's position equal to param position. So what I can do is I can actually set a default character for this to call, and this goes for any function you can do this with. So if I was to say car position and then, call the game object constructor, I can not put a second parameter and it will automatically say that is a space. So there's a function that you guys have probably been using a lot that already does this, but you haven't seen the declaration of it, so you probably didn't know that it was doing that. So can anybody think of a function that you use a lot that automatically does stuff if you don't put an extra thing at the end that like picks up on something and fills it in for you? Really common function. You've hopefully been using it a lot in the first assignment. So what about let me pull it up. Okay. There's this one. So this was just, that random code I wrote otherwise. So what if I'm reading in from a file? Look at this line versus that line. Oh, it doesn't let me highlight both of them. Oh well. But if I look at like 175 versus 172, oh, 176. This get line, I didn't put an extra character, right? And this get line, I put a comma. So if you remember, what this does is this will read a line until it encounters a comma, and this will read a line until it encounters a line feed. But I called them with different amounts of parameters. So what happens is there's a default parameter for getLine where if you don't give it a character, it says that it's a line feed. So what they did is they have something, if I was to write it, they have something like, void getLine, and it takes an iStream, a string, and a character. Read to, let's just say. So that has something like that. If you don't give it a variable for the last parameter, it will just automatically say, well, that's line feed. So that's a popular example of something that uses a default parameter. And so that's nice because if we, don't have something, but we still want it to get filled in, we can just give it a default parameter here. So you'll notice in the clear screen thing, I just create a new game object with actually the default constructor, but I could give it a position and it would just automatically say that symbol is space. So if I was to go to, like, let's just say the player here, let's say I change this to default character X, and I remove this. So I'm calling the player constructor with just a position, but its constructor requires a position and a character. It will automatically say that character is X when I run the game, assuming I added the player to the screen, which I should. Yeah, the player should show up, I hope. I don't think it did last time for some reason. Yeah, there we go. So now the player's next. So I can set a default, and it'll just fill it in for me if I decide not to do anything with it. Hopefully that's clear. Again, stop me if you have questions. Okay. So I think that about covers everything in that class. I think I wrote everything. And I mean, it seems like our game works, right? I already wrote that stuff. So maybe we'll just talk a little bit about one more thing. I hate to throw a whole lot at you, but there's a lot of important stuff with object-oriented programming. And maybe I'll just take 10 minutes to answer questions if you have any. So the last thing I really wanted to talk about was static variables. So I didn't actually write that into my code because I didn't think I'd have time, honestly, but here we are. So it might be beneficial for my game if every game object in it had a ID that I could use to identify it, maybe write some functions that look it up with the ID or whatever. So what I could do is, let's just say I give an ID, and again, the common practice for this is we make the variable private, and then we just do a function called getID. Oh, there was something else I wanted to talk about. That returns the ID. And I totally just forgot what it was. Oh, yes. But let's use static variables next time. It might take me a while to explain it. So I'm going to create an ID. We'll worry about that later. The last thing I wanted to do was talk about scope resolution operator, which I used earlier. But so it's common in C++, at least, to write all of your declarations in the header file and then write all of your implementations in a actual C++ file, like a .cpp. So you are familiar, hopefully, with function prototypes that we write normally in C++, which is just a consequent of the compiler only making one pass. So normally we give the function names up here, right? We don't actually write the function, and then we use these method or function names, when we need them. So let's just say have clear screen somewhere right here, and then I call it right there, even though I haven't actually written clear screen yet. And I end up doing that down here, right? We can do the same thing with classes. So I've been writing all of the bodies of these functions and constructors right underneath where they actually are, but I have the option to do it similar to a function prototype. So for instance here, let's say we have this add to position function. Actually, let's do a couple. So let's say I want to write move and bounds, but I think it's a little bit clunky to do something like I did here, where I write it all on one line. Or even if I was to write it normally, like this. You might think things get a little bit cluttered, which I guess is fine. I usually don't mind it that much. But there's also the problem, which has to do with our function declaration stuff, is if we have a lot of these header files, and some classes in one header file reference other classes in another header file, and they're all over the place in terms of order. Like, I make position, and the position uses a game object, and the game object already uses position, and these are out of order, right? This is going to know what a position is because it came earlier in the code, but this shouldn't actually know what a game object is because it's later in the code. If I compile this, it should give me an error. Yeah. Unknown object specifier, right? It says. So if I try to compile this, it gave me an error because game object isn't declared yet, because this goes from top to bottom. So it says, oh, well, I don't know what a game object is because I haven't encountered it. It wouldn't hit it until it gets down here. So to avoid problems like that, what we usually do is similar to a function prototype. We'll give the name of the function, and then we'll write it somewhere else. So what I'm allowed to do is, if I didn't want to write move and bounds in here, I just wanted to write the name, I'm going to write the name in there. It works like a function prototype in that it just it gives the name, and now the compiler knows the name exists, so I could use it and it will look it up later, whenever we write it. What I can do is go to a C++ file, a CPP file, some sort of body. We can have multiple CPP files, and I'm going to write it there. So the way we do that is we just write the same exact function. And so the problem with that, which you'll see already, it doesn't know what position is. But it should know position is because that belongs to the game object class. So when we're writing these, we need to specify where the actual class that we're writing the function for comes from. Because I could make another function or another class here called class test that also has a public or private or whatever function called void move in bounds. And so the way it's going to have to tell the difference between this one, the move in bounds from test, and the move in bounds from the game object class, is by specifying what class it comes from. So the way I do that is I gave the name of the class, and then I do 2 colons, which is called the scope resolution operator. So this is the game object version of move in bounds. And so I can write the body of it outside of the actual class, like a function prototype, and it'll just work. And it will know this one belonged to game object because I put the game object scope resolution operator in front of it. Okay. And then so if I wanted to likewise do the test version of that one, I would do test move in bounds. And then this should compile now. It ran, and then move in bounds should work. If I was to move all the way to the right, you'll notice I'm not allowed to move past the wall, so it recognized that I wrote the move in bounds function here, and then it belongs to game object. So whenever I do a move in bounds call on a game object, it knew that was the code to call. Okay, I think that's the last thing I for sure want to talk about. We'll talk about static variables next time, but you don't need those for the assignment. You do need this scope resolution operator, or at least you should use it. Last thing I'll mention before I just take questions, I guess, is that you don't have to use the scope resolution operator. Or sorry, you don't have to like write the function outside using the scope resolution operator all the time. It's good practice to do so, but just like it's a good practice to write these function prototypes and then write the actual body down here and not just dump all the code up at the top of the program. I recommend, if it's a really, really simple, like 1-2 line code function, just write it in the body. So I would never, ever take get car, get position, get ID, and move those out there, do the scope resolution operator, write the whole body outside of it, because these are so simple that you can just kind of keep them in the inside and assume they work, because they don't really rely on anything else, and they're just one line of code. It's not too complicated. So if you have like really simple things, I recommend just keeping that in the body of it. But if you have like a long piece of code, or a long function with a lot of code, or if you have something that relies on other classes, then you should definitely move it to the outside and use that scope resolution operator. At least in C++. If you're doing more object-oriented languages, then I would just throw it all in there, and it's good and it works. Any questions on all of that? I think I'm just going to spend the last few minutes taking any questions that anybody has, just because I threw a lot at you guys today. But it's all very important. No question free? Okay. I guess on that note, everybody is free to go a little bit early. If you have questions, I'll stick around for another at least like 5-6 minutes, maybe longer. So up to you. You can go if you want. Lecture code for Wednesday on Canvas. What did I do on Wednesday? That was like the animal.h, right? I did not. I can, though. Let me find it. Error containing undefined reference on your code. Yeah, send me either an email or a DM on Discord with that. I'll try to answer it for you. It might be a little bit before I get to it, though, just because I have class after this. But send me that stuff and I'll try to respond to you as soon as I'm free. You have the same problem? Okay, and also send me an email. It was about undefined reference. I guess just in case it takes me a while to get back to both of you guys. I don't know if Dylan already left. What was I going to say? An undefined reference means that you probably haven't declared the variable yet. So make sure that you are like declaring it with like int x or string y or whatever before you use it. So also for classes, the difference on public and private is just what can be accessed across the entire code. Yeah, exactly. So yeah, public can be accessed anywhere. Private can be only accessed within that class, with the exception of friend functions, which we'll talk about later. And there's another keyword in C++ and pretty much every other language called protected that has a different rules for that. But we haven't gotten to the point where we're allowed to or where we can really talk about it and it'll make sense yet. Yeah. So modifiers just affect where you're allowed to use data. And it's just, you don't really need them for programming, but it's just niceties for if you come back and write something later, or if somebody else is using your code, they know what they're allowed to use and what they shouldn't use. Because maybe you're just writing something really convoluted, and you don't want them to mess it up. So you stop them from doing it by using private. Oh, wait, let me find... hopefully I kept it. I should have the example from Wednesday. It wasn't that in-depth, so I probably didn't keep all of it. I do have the header, at least. I'll post that. All right. I guess if nobody else has any questions, I guess we're going to call it a day. So I will catch everybody later.